A car freewheeling on a straight road experiences retardation, which is proportional to the square of its speed. So acceleration, or it's retardation, it's slowing down, is equal to, it's proportional, so it's k times a constant times the square of its speed, v squared, and its speed is reduced from 20 to 10. In a distance of 100, calculate time taken to travel 100. So time, let's start with dv dt here. We know dv dt is acceleration. So minus dv dt is equal to kv squared. So we get minus dv over v squared is equal to k dt. And if we integrate both of these, I should probably put it in here really. Put the minus in front. So speed is starting at 20, it's reduced from 20, so we get velocity at time t. So if we integrate v to the minus 2, it's going to give us v to the minus 1 over minus 1, which is equal to minus 1 over v, and we have the minus in front, so that will then give us a plus 1 over v. So we'll have 1 over v starting at 20, and velocity at time t will be equal to kt between t and 0. So coming across, we're going to get 1 over v minus 1 over 20. One over 20 is equal to kt minus 0, so just kt. So 1 over v is equal to kt plus 1 over 20. So I make the right a single fraction. It'll be 20 kt plus 1 over 20. And inverting them gives me v. V is equal to 20 over 20 kt plus 1. So we have velocity and time. Let's look at distance and time. So s is equal to ut plus a half at squared. ds dt is equal to u plus at, which we know is velocity. So ds dt will give us changing velocity into distance and time. ds dt is equal to velocity 20 over 20 kt plus 1. Simplifying this down, we want distance, so we need ds is going to be equal to 20 over 20 kt plus 1 dt, and maybe I'll just take that 20 out. It's equal to 20 times 1 over 20 kt plus 1. So I'll put my integral in here, dt and ds. So we want to find the time taken to travel 100 meters. So from 0 to 100, we want to find the time taken. So on the left hand side, we're going to get s between 100 and 0 is equal to 20 times 1 over x. It's going to give the natural log of x, which is 20 kt plus 1. And then we'd have to multiply by, if we differentiate this guy with respect to t, we're going to get 1 over 20k, and our 20s will cancel, and this was all between t and 0. So we're going to get 100 minus 0 is equal to, tidying this up, we're going to get 1 over k times the natural log of 20 kt plus 1 between t and 0. So tidying this up, we're still going to need to find k. I think that should should be able to look back up here now to help us in a minute to find a value down here, maybe 20 kt plus 1. We can simplify that guy. So 100 is equal to 1 over k. Putting t in for t and then 0 in for t, we're going to get the natural log of 20 kt plus 1 minus, let's give it a bracket, the natural log of, this will be 0, so just the natural log of 1, which we know is equal to 0. So 100 is equal to 1 over k times the natural log of 20 kt plus 1. I don't need that first bracket. So we need to go back up here. Velocity, again, we were given information, it's reduced from 20 to 10. So let's look at when v is equal to 10. We get this guy here will be equal to 10, so the bottom will need to be equal to 2. 20 divided by 2 is 10. 20 kt plus 1 is going to be equal to 2. I think we can replace that 20 kt plus 1 down here. 20 kt plus 1. So we're going to get 100 is equal to 1 over k by the natural log of 2. So we get a value for k. Now k is going to be equal to the natural log of 2 divided by 100. Natural log of 2 divided by 100. So 20 times the natural log of 2 divided by 100 times t plus 1 is equal to 2. So now we just have t as the unknown. So 20 natural log, so it's the natural log of 2 times t over 5 is equal to 1. So natural log of 2, so 5 is equal to natural log of 2 times t, so 5 over the natural log of 2 will be equal to t eventually. And we type this into our calculators, it comes in about 7.2 seconds.